Hello, everyone. It's good to see a lot of familiar faces here. I think I've seen a lot of you over the past year. So my name is Luke Hopkins. I'm a developer relations engineer for XR at Google. Is that someone outside? Or and with me, we have Trisha Becker, who's a product manager at Unity. So feel free to say hello. So thank you very much for joining us. Today, we're going to go over the collaborative efforts that we've made on Android XR between Google, Unity, and our partners over the last year. As we know, Android XR is an extension of the Android ecosystem. It's expanding on a wide range of form factors to bring the experiences you know and love to Android. We've made it intuitive to bring your existing XR and Android applications into this space. We're leveraging a lot of Android technologies that you're already building with if you're building those Android apps. On top of this, Android XR uses OpenXR and is built as a Vulkan-first platform. These standards kind of make sure that you have the best compatibility for your existing applications, where we really want to ease that burden and cost of porting your applications. Samsung recently announced their first headset, Galaxy XR, which I think released a couple of weeks ago. So big congratulations to Samsung getting that device out there. It was a great moment for you all. I know a lot of you have published their apps or been developing for this headset. So I think it's a big warm welcome to have that first headset out in the market. And on top of this, Android XR is also expanding with up-and-coming devices like Xreal's Project Aura. So I think a lot of you will get to see some demos today in the next couple of days. So that's a really interesting new form factor. But again, choosing Android XR as that layer, so a lot of the experiences you've already been developing will just work on that device. Earlier this year, we had build camps over the world. We're working closely with partners such as yourself who want to collect feedback, understand what some of your wants and features were. So thank you very much for providing that and working with us over the last year. We continue to work to get feedback from you guys. So thank you again for coming back and coming to this event. So feedback is always welcomed. We have our office hours over in the corner. You'll see me and Trisha walking around. I'm a very open person, so feel free to poke me and give me any feedback you like. Don't just take my word for it. We've got a couple of examples of feedback we've been hearing back from a partner. So Trip mentioned how seamless porting their application has been. And then we also have the demo teams. So Resolution Games have also mentioned how easy this process. And on top of this, we have over 50 plus XR differentiated apps and experiences available on the Play Store today. So be sure to check those out as well. Now I'd like to hand it over to Trisha Becker from Unity to talk about Unity 6 and Android XR.
Thanks, Luke. So before we dive into the technical side, let's just talk about why Android XR. So first, reach. If you've already built on OpenXR, then most of your work carries over. You can bring your project to new devices, new audiences, without rebuilding everything from scratch. Second, familiar tools. So you're still using the same Unity workflows, the same cross-platform APIs. So bringing your app to Android XR is going to feel like a continuation of your work, not a rewrite. Third, the ecosystem. So Android XR isn't just one XR headset. We're seeing that here today. It's a growing platform that's expanding from headsets to next-gen XR glasses. So the work you do now sets you up for everything that comes next. And then finally, timing. A lot of us have been in this space for a long time. We've been waiting for what we're starting to see. We know that XR and AI are moving fast. Together, they're unlocking experiences that we haven't seen before. So it's just a really cool time to be creating in this space. So with that in mind, let's take a look at how Unity's XR ecosystem makes all of this possible. Let's start with the packages that are at the core of Unity's XR stack. So if you're a Unity XR developer, you're probably already using these. You've got the OpenXR plugin. So this is your cross-platform baseline for OpenXR platforms. It gives you the fundamental features, so things like tracking, input, and performance features that Android XR uses. You've got AR Foundation. This is where the high-level mixed reality features live. Things like planes, anchors, and occlusion. If you've built augmented reality before, the workflows feel the same. Those workflows now apply to HMDs like Android XR2. And then XR hands. So Android XR follows the OpenXR hand tracking spec. So things like joint data and gestures flow through this package. And then here's how all of those packages connect behind the scenes. So at the top is your app code. This is your gameplay logic, your UI, basically everything you've built for your experience. That connects down into Unity's XR layer, which is made up of packages like AR Foundation, XR Hands, XR Interaction Toolkit, and our newly released Composition Layers package. Under that sits the XR SDK layer, which is the bridge to the actual platform runtimes. And then finally, into your provider plugin. This is for the device you're targeting, so which in this case is Android XR. The nice part here is that you don't have to think about all of these layers. Unity handles all of the plumbing here, so everything is going to feel consistent across platforms. And because Android XR is an OpenXR platform, the core OpenXR plugin in Unity already knows how to talk to it. So if you're already working with OpenXR today, there's a high likelihood that 80 to 90% of your app is on the way to targeting Android XR devices. So let's zoom in a bit on OpenXR. OpenXR is an open standard that defines how apps talk to XR hardware. So it gives us a shared foundation for building features the same way across multiple runtimes, and it's one of the main ways that Unity connects to XR runtimes today, especially for head-mounted devices. Unity's commitment to OpenXR goes back to the beginning. We are a founding member of the working group, and today we ship multiple OpenXR packages in production, like Android XR. And there is a lot more coming next year. So things like spatial entities, a more modern, scalable interface for AR features are on the horizon, along with continued standardization efforts. So all things which point to an even more stable and robust OpenXR future. And here's a look at what's currently supported for Android XR across Unity's XR packages today. So on the left, you've got the OpenXR plugin. This is where the core OpenXR features live. So you've got things like controller input, eye tracking with foveated rendering, a lot of graphics features, refresh rate, space warp, multi-view render regions, and recently added automated dynamic resolution. In the middle, you've got the OpenXR Android XR package. That builds on top of that with additional capabilities. So pass-through, plane detection, persistent anchors, raycast. We just added support for face and object tracking, occlusion, meshing, light estimation, and performance metrics. There's a lot in there. And then lastly, you've got XR Hands, which gives us everything that you need for hand tracking and hand interactions, like gestures and hand mesh support. Okay, let's talk about the higher level Unity systems that you can layer on top of Android XR. So especially if you want to build mixed reality experiences. And the biggest one here, no surprise, is AR Foundation. So AR Foundation has been around since 2018. It was originally for AR Core and AR Kit, so if you've built mobile AR, you've probably used it. In 2024, we expanded it to include HMD support. So that means features like planes, anchors, and occlusion come through a single API, even if runtimes expose them differently underneath. So if you're building mixed reality experiences for Android XR, AR Foundation lets you write that logic once instead of for each platform. And here's what that looks like in practice. So the features highlighted here, you've got device tracking, planes, anchors, meshing, and occlusion. They're supported across runtimes like Android XR, Quest, and Vision OS through AR Foundation. So if your project is using these systems today, you don't have to reinvent anything to support Android XR. You just plug into the same APIs. So just a quick recap. These are the big things to remember. Unity gives you a solid cross-platform baseline. You've got the OpenXR plugin, AR Foundation, and XR Hands. These are the core tools that you already know. The Android XR SDK builds on top of that foundation with platform-specific capabilities like light estimation and performance metrics. And then if you're already using Unity's XR stack, you're set up for Android XR. The workflows and APIs stay consistent. And then together, Unity plus Android XR make it a lot easier to build and ship the next wave of XR experiences. And with that, I will pass it back to Luke.
Thank you. Thank you very much, Tricia. So here at Google, we're excited about how XR and AI can come together. We think it's got a lot of huge potential. So we recently released the Firebase AI Logic SDK for Unity. So we're going to dig into how you can use this in Android XR together to power Google's kind of Gemini models and how you can get that into your Android XR applications. The Firebase AI Logic is a go-to solution for Unity developers on Android XR. So it allows you to use these Gemini models within your application. It offers features to help you get production ready, such as remote config. This integration allows you to upgrade your models and your prompts without needing to release a new build. It also has app check integration, so you can protect your Gemini API calls from abuse. And then on top of this, we have the Firebase AI Logic, which includes AI monitoring dashboard, so you can keep track of the core volume and the associated costs to this. Now we know that the Firebase AI Logic allows you to add Gemini to your app. Let's do a deep dive into some of the amazing experiences you can create with Gemini and enhancing your applications with features like interactive conversational storytelling. You can provide users with an audio conversational interface, which can be used to ask questions such as text, metadata, and it can add this new layer of interaction for linear media, games, and XR experiences. This takes advantage of Gemini's multimodal bidirectional streaming capability, which enables users to upload text, talk to Gemini, and get real-time voice responses. Dynamic image generation. This allows users to describe in natural language a desired element they wish to generate with AI to create 2D graphics. You can create more immersive and dynamic environments that's customized to users' experience. And this utilizes Gemini's image integration. Intelligent NPCs. You can make NPCs aware of the user's context, providing them with text, images to describe the player and its environment, so you can have more dynamic conversations and storylines throughout your experience. A lot of this takes advantage of Gemini's multimodal input and text output feature set. Gemini is a family of multimodal AI models developed by Google. It's designed to understand, operate across, and combine different types of information such as text, code, images, and video to provide appropriate and accurate response to the user. This response, or the output, can be the form of text, image, and audio. There are several Gemini models available to use, and which one is best for you kind of depends on your budget and what you're trying to accomplish. So Gemini 3 Pro is the highest performance model. It improves on the capabilities, which now includes thought. So this allows you to have more of an improved performance and response by having that thought element to it. And then we also have Flash, which is a well-rounded model in performance and latency, and is built for more agent experiences. So if you're not sure which model to use, we normally recommend Flash being the go-to model to start with. There are 2 API providers as well for the Firebase AI Logic SDK. We have the Gemini Developer API, which is a great fit if you're just starting to add generative AI to your applications. It has a no-cost tier to help you start prototyping and explore possibilities quickly and without friction. It also has a pay-to-go model, which is suitable for production apps. On top of this, we have the Vertex API, the Vertex AI Gemini API, which remains the go-to for apps needing enterprise-grade features. So when availability and governance is kind of critical for your production app, Vertex API is kind of that go-to for those demands. Both of these APIs are supported in the Firebase AI Logic SDK. So depending on your needs, depending on which one you might want to use. But again, for developers in the room, we always recommend going to the Gemini Developer API first, as that's really going to help you get started as quick as possible. Here's an example of in Unity generating text output using an image and text input. In this example, we use Gemini to list the primary colors in the photo. So this example shows quickly and seamlessly how AI can be used within your XR application. Here's a quick snippet that shows how you can generate a multimodal prompt. We add an image, we add text, and we generate a response from Google, from Gemini even. So from here, you can see that we're setting our backend to be the Gemini API. We set the model we want, and then from there, we can add some text, add an image, and then from there, we can just log our response that we get back from Gemini. So really, really simple, not many lines of code. So we definitely recommend you guys trying this one out. You can also use the Gemini Live API and the Firebase SDK. This allows users to create real-time, two-way conversational AI apps by streaming data like audio, video, and text to the Gemini model and receiving an immediate, low-latency response back. This means you can have human-like conversations with the AI that processes what it hears and sees as it happens. The Gemini Live API is a stateful API that creates a WebSocket connection to establish a session between your app and the Gemini server. This feature is currently in preview, and you can already start experimenting with it today. For full details, you can see the Live API reference documentation in the slide here. So there's a quick QR code. You can go and see the documentation. It also includes full guides on how to set up the Firebase project and how to send prompt requests to the Gemini models. Along with these amazing packages from Unity, Google also have the Android XR extensions for Unity package. This is more designed for experimental features or to enhance functionality on top of Google's packages. So this package really supplements the Unity OpenXR package from Unity. So over the next year, we've added features to the Android extensions for Unity. We have QR codes that can be placed in the physical environment, and the QR code tracking APIs track where it is. And from there, you can put 3D kind of models in your environment, and it can track where those QR codes are. We have system states that provide the current state of the user's blend mode. So for example, if the user already has pass-through on when they're coming into your experience, you can read the state of the system and then keep things persistent with them. This also goes for if they have gaze or hand input as their primary way to interface rather than just hands. You can read this system state, and from there you can know what the default settings are people want on their headset. We also have battery states to understand the current battery status and levels. So if you're doing a high-performance application, you feel like those battery levels are going to start going low, and you want to start making some more optimizations or maybe guiding the user to save their progress and save where they are, you can definitely be aware of the battery states as well. And we also have experimental features such as body tracking. So please note, if you use any of the experimental features that we have listed in this SDK, you won't be able to publish to the Play Store. But these experimental features are more intended to get early feedback from developers such as yourself. And feedback is welcome via our developer website, or again, whilst you're here in these lovely rooms with us, you can poke us and ask us a few questions. So we're always welcome feedback for these APIs. Let's just take a quick sample of how scene meshing works. So first, we'll need to request for permission, as we're doing a lot of scene understanding. We'll get an instance to the mesh subsystem. We'll listen for events when the system has mesh information. And then from there, we'll generate a mesh as an async function, which passes information basically back to a mesh filter in Unity. So I'm going to do a quick snippet. So this is how quick and easy it is to kind of get that mesh information back from the scene meshing API. And from there, we can generate a mesh and pass that information back to the mesh filter within Unity. We have a lot of these samples as well inside our Android XR extensions. So if you download it today, you'll see a little samples tab inside there, and you'll see a lot of the source code there if you want to look at how scene meshing works. Next, let's take a look at body tracking. So again, we start by requesting permission. So we have the body tracking API. Next, we'll check if the extension's enabled, ready. And this API works really well with the Unity AR Body Manager. So it's in the AR Foundation package. And what you can do is you can send a lot of information from this API directly to the AR Human Body Manager component. And then from there, it just updates the model and uses a lot of those components that you're already well aware of within Unity today. For this example, what we're also adding is we're looking for these changed events And then I'm just logging a lot of this debug information out from this. So let's say you've got the animation that's all rigged up and you've got your hands moving around on the body track, but you might want more information on top of that, and you might need more details back from the body information. You can easily log this information and get when any of those body information changes, and it's a quick way to implement any new features that you might want on top of this if you're not doing animation or tracking with the body manager itself. Here we've got a quick demo of how you can use marker tracking and then use that position to sync a 3D model to it. So here you can see we've quickly been able to scan where that marker is in position and then just overlay some 3D content on it. So this is a great way for tracking information in your scene. If you want to get an idea of how to build with Android XR and Unity, we have a full set of extensions in action, and we can see those samples on GitHub itself as well. So this is a great place, kind of our showcase place for all the samples, all the APIs we've been using, and it's kind of a fun little playground for a lot of our engineers to be submitting to. So feel free to download those examples. You can run all the source code, and if you want to give feedback, happily make a pull request or just ping one of us. Again, this is more of a playground, so you can see what's going on. Thank you very much. I'm going to invite Tricia back to the stage, but thank you very much for your time today.